Ladies and gentlemen, in the name of the Vice-Chancellor of this university, Professor ADEBAYO SIMEON BAMIRE, we welcome all of us here. May I please crave indulgence to please stand and remain standing for the Vice-Chancellor's procession in respect of this 419th inaugural lecture of our great university. Thank you.
Kindly be seated, please. Thank you. I'd like to welcome everyone to this inaugural lecture, the 419th inaugural lecture of this great university, Obafemi Awolowo University. To be presented by Professor DJ Oyedele. The title of the lecture reads Nexus of Physics, Soil Architecture, Sustainable Environment and Food Security. Professor Durodoluwa Joseph Oyedele was born in Arigidi, Akoko, Ondo State. His early education began at St. Stephen Primary School from 1967 to 1972, followed by Akoko Anglican Grammar School 1973 to 1978. He proceeded to the University of Ife then, where he earned a B. Agric in Soil Science in 1983. After completing his National Youth Service at the Anambra State College of Education, 1983 to 1984, he pursued postgraduate studies at Obafemi Awolowo University, obtaining an MPhil in 1988 and a PhD in 1997. Specializing in soil physics and soil conservation. Professor Oyedele joined OAU's Department of Soil Science in 1990 as an assistant and rose steadily to become full professor in 2008. With over 100 publications in reputable national journals, he has made significant scholarly contributions reflected in his Google Scholar citation count of 2,376 and H-index of 25. His administrative experience includes serving as acting head from 2006 to 2008 and the substantive head of the department 2011-2014. He was Dean of the Faculty of Agriculture in from 2017 to 2019 and two-term member of the OAU Governing Council 2021 to 2025. He has also contributed extensively to university governance through numerous committee roles. Internationally, he has held research and visiting positions in Denmark and Italy, and is affiliated with global scientific bodies such as the Soil Science Society of America and the International Union of Soil Scientists. He has attracted research grants exceeding $8 million from organizations including IFS, UNU, IDRC, CIDA, and the Netherlands government. His mentorship record includes supervising many undergraduates, 24 master's students, and 7 PhD graduates, several of whom are now professors across Nigeria, Canada, and the US. His recognitions include Outstanding Lecturer of the Year in 2016, African Agent of Change 2023, and the Most Impactful Education Personality in Africa. That was in 2026. And a nomination also for the Visionary Scientist for Africa Agriculture Award at the 2026 SSSA Conference, Oregon, USA. Professor Oyedele is happily married with children, and I hereby like to call on Professor Durodoluwa Oyedele to present his inaugural lecture. Thank you.
Mr. Vice-Chancellor, sir, the principal officers of the university, distinguished guests, ladies and gentlemen, it is with a grateful heart that I'm standing before you today to present the 419th inaugural lecture titled The Nexus of Physics, Soil Architecture, Sustainable Environment and Food Security. This will make the 8th inaugural lecture to be delivered from the Department of Soil Science and Land Resources Management. Many people have asked me the question on why I accepted to present at this time, considering the unique series number of this lecture. And my answer to them is that before Decree 419, which is about acquiring wealth by false pretense, God had already provided a biblical 419 to counter it. Because in Philippians chapter 4, verse 19, the Bible says, "My God shall supply all your need according to his riches in glory by Christ Jesus." True wealth comes only from God Almighty. Introduction. Mr. Vice-Chancellor, sir, permit me to dwell a little on my background. I was born at Arigida Akoko in Ondo State to Mr. SIMEON Oyedele and Chief Mrs. Hannah Oyedele, both of blessed memory. Both of them were illiterates. My father was a farmer, while my mother worked as a cook in the only secondary school in my town then. My mother especially was passionate about education. I started my education at the St. Stephen United Primary School, Arigidi, in January 1967. I almost never completed school, as I dropped out of school twice. The first time was I voluntarily dropped out of school when I was in primary 2 because I thought my classroom teacher, who was also the school headmaster, was unnecessarily harsh on me because of my fingernails. I did not realize then that my fingernails grew faster than those of other pupils in the class. When we all trim our fingernails on Monday, mine would have grown by Friday. And it was always difficult to convince him that I was not just being disobedient. I, however, found my way back to school after spending the rest of the remaining 2 terms going to the farm with my father. Luckily, the primary 2 class was overpopulated, and I was moved to join my former classmates who were already in primary 3, and by so avoided the teacher who was teaching the same class. The second time was when I was in year 1 of modern school. This was because we were more engaged in farming than studying. However, a day I can never forget was Saturday, March 3, 1973. That was my 12th birthday, when my mother gave me the money for secondary school entrance examination form, through which I secured admission to Akoko Anglican Grammar School, Arigidi, in September 1973. My first encounter with physics in secondary school was an interesting one. It was in Form 3, and our teacher was a youth court member who made the subject very complicated. Even though I was doing well in other science subjects, but due to lack of good counselors, I decided to drop physics in Form 4. I later discovered this to be a big mistake when it was time to apply for university admission, as I realized that I needed physics for my courses of preference, which was engineering and pharmacy. It was only agriculture that was accepted that I could do without physics. Therefore, I applied for soil science at the University of Ife as my first choice, and for agronomy at the University of Ibadan as my second choice. However, despite my initial school challenges, it is to the glory of God that I still entered the university at the age of 17. On getting to the university, I realized that I could not run away from that same physics. I registered for physics in part 1, and I failed physics 105, which was the only course I ever failed in the university. Again, coming face to face again with physics in my part 3 was another challenge. However, the lecturer, Professor Patrick Oladikwano, taught the course in a highly practical and engaging way. Even though the open book tests were challenging, they deepened my interest and made me appreciate the subject even more, and it opened my eyes to the opportunities within the field. It was during that period that I made up my mind to specialize in soil physics, despite having a weak background in physics. I returned from my master's program immediately after my youth service in 1984, and I completed my MPhil and PhD degrees respectively in 1988 and 1997 under Professor Aino. I was employed as an assistant lecturer in 1990 and rose through the ranks to become a professor in 2008. Soil physics is a branch of soil science that studies the state of matter and transfer of energy in soil. It describes and quantifies how energy and matter are transferred within the soil and uses models to make projections on the impact of this and apply external forces on soil. This branch of soil science involves the application of some fundamental laws and theories of physics to describe soil physical properties and processes. Soil architecture, which is also referred to as soil structure, refers to the spatial arrangement of soil particles and the pore spaces between them. Young and Crawford in 2004 described soil architecture as a dynamic self-organizing system influenced by biological activities. The building blocks of soil are the soil primary particles of sand, silt, and clay. These primary particles are provided by geological processes such as weathering of rocks and minerals. These minerals alone, without modification, will result in structureless mass as it is obtained in Mars and Moon. On Earth, however, these materials are bound together through various chemical and biological processes to form soil aggregates. Soil architects are the biological organisms that physically build and maintain soil structure. These include the primary architects such as earthworms, which are also referred to as ecosystem engineers because they redesign the soil environment. The microarchitects are the soil fungi and bacteria, which either physically or bind or produce materials that bind soil materials into micro aggregates. Plant roots provide the structural support, while the tunnel left behind by dead plant roots serve as channels for air, water, and transport of nutrients. However, when the soil is overused or polluted, these architects are killed and soil structures collapse, leading to inability of soil to sustain the ecosystem, and the soil technically dies. The Yoruba proverb says, Eriku magudu fije, efonku magudu fije, magudu waku kurenti ojeun, meaning that the elephant died and was devoured by magudu. The buffalo died and was similarly devoured by magudu, but at the death of magudu, there was no one else, one left to eat it. And that is the story of the soil. When the soil dies, it becomes practically unproductive. The link between physics and soil architecture. Mr. Vice-Chancellor, sir. The soil is not just a collection of particles, but a complex, organized porous medium containing myriads of microbial lives. While soil architecture defines the arrangement of soil particles and the pore spaces between them, physics explains the implication of these arrangements on soil processes such as air and solute transport, the response of soil to stress and strain, and the impacts of soil structural configuration on the bearing capacity of soil, among others. To do this, theoretical models in physics are used to quantify soil physical state and processes occurring in soil. For example, in the 1830s, Henry Darcy who was a French engineer, was tasked with designing a system to bring clean water to the city of Lyon in France. To achieve the goal of bringing water through a 12-kilometer aqueduct to the city, he realized he needed to understand exactly how water moved through sand filters, which is used to purify it. Darcy conducted a series of experiments by pouring water through vertical pipes filled with sand. He measured the pressure of water and the velocity of flow at the point of discharge. He observed a consistent pattern that regardless of how much sand he used, the velocity of the water flowing through the sand column was directly proportional to the pressure drop and inversely proportional to the distance the water traveled. He, however, noted that every type of sand or soil had its own, what he called personality, which he termed the hydraulic conductivity. The result of this is the popular Darcy's law, which is now universally useful in irrigation and oil exploration. This equation was further modified to account for the complexity of the soil by Richards, and is now referred to as Richards' equation. In addition, Vogel in 2010 used CT scan to demonstrate how a minute change in soil architecture can restrict water flow by several magnitudes in a phenomenon known as preferential flow. Quantitative relationship between soil architecture and soil physical properties include this S theory of Dexter, which is in equation 4, and the gas diffusivity model of Muldrop in 2001 in equation 5. These two models further demonstrate the extent to which configuration of soil pores and shape of soil aggregates influence the ability of soil to transmit air and water. In soil mechanics, which deal with the soil strength and rheology, the ability of soil to resist deformation depends on soil architecture. Mechanical strength of structural soil with comparable internal parameter depends on aggregation, actual and maximum pre-drying and composition and arrangement of the pore system. For comparable grain distribution and pore water pressure, soil strength increases with aggregation. Soil degradation and civilization. The history books often tell us about the great early civilization, how most of them declined and lost their relevance because they were conquered by later, stronger civilization. What most history books do not mention is that the decline of most of this early civilization started from the poor management of their soils. These societies were fundamentally tied to the health of their soil. The Sumerian civilization, for example, intensified irrigation in the plains of rivers Tigris and Euphrates, leading to soil salinization, which culminated in crop yield decline, forcing farmers to switch from wheat to salt-resistant crops like barley, and eventually leading to loss of food security. Similarly, the Maya Kingdom in Southern Africa collapsed in the 9th to 10th century BCE, was attributed to indiscriminate deforestation, leading to soil erosion, poor crop yield, and eventual loss of food security. A country that does not manage its soil properly cannot be food secure. Meanwhile, a non-food secure nation cannot withstand external aggression. Soil and national security. Mr. Vice-Chancellor, sir, Nigeria is currently engaged in fierce battle with insurgents, most of whom operate in uncharted territories of the country. Soil information system is essential and may contribute to our efforts in defeating them. Good information on the soil physical properties, such as the soil trafficability, ADEBAYO limits, cone index, and so on, by the military may determine whether a nation is winning or losing a battle. The strength of soil is measured at the external pressure the soil can withstand before it yields or before its structures collapses. The load-bearing capacity of a soil is dependent on its strength and moisture contents. This has implications not only for infrastructure like roads, rail lines, and buildings that are on the soil, but also has military implications. For example, the early campaign of the Russian army in Ukraine was significantly slowed down by the Ukrainian soils. The deep soils of Ukraine, which also refers to as the Chernozem, are some of the best soils for agriculture. But when wet, they are not trafficable and could not bear the weight of the heavy Russian tanks, which forced them to move in convoys on paved roads. Thus, their tanks and their supply lines became predictable and vulnerable to attack by the Ukrainian drones. In Nigeria, we do not have a detailed information on the properties of our soil across different geographical locations. The few studies done have focused on soil fertility, but very few on soil physical properties, such as soil strength. A detailed understanding of the mechanical properties of Nigerian soils, such as cone index, trafficability, and so on, will be useful for the military in determining the suitability of different vehicles on different terrains in their quest for national security. Mr. Vice-Chancellor, sir, talking about my contribution, the focus of my study has been on identifying factors that predispose soil to degradation, how to prevent this, and on developing methods to improve soil physical properties and make them resilient to degradation. In the course of these studies, I have collaborated with scientists from diverse disciplines ranging from physics, chemistry, sociology, food science, crop science, agricultural economics, agricultural engineering, and within and outside Nigeria. Soil erosion studies. Soil erosion is an energy process. The kinetic energy process possessed by falling raindrops impact on soil surface, and detaching soil particles is the precursor for soil erosion. The kinetic energy of raindrops depends on their mass and their terminal velocities at impact. When rainfall intensities exceed infiltration rate, overland flow is generated, and the flowing water begins to acquire sufficient carrying capacity to transport the discharged soil particles. We studied the interaction between rainfall at different intensities and overland flow in causing erosion, with the use of a laboratory rainfall simulator in combination with an overland flow generator. We developed an empirical predictification relating soil erodibility to some easily measured soil properties, given in equation 6. In the study, maize grain were consistently highest in the deeper lower landscape position, ranging from 2.8 tons per hectare to 3.5 tons per hectare. And we also developed an empirical relation that relating maize with some identified factors. Also, in a study to quantify the changes in soil productivity, the depth of soil removal in an erosion soil, in a simulated experiment, topsoil was incrementally removed to depths of 5, 10, 15, and 20 centimeters, with plots without removal serving as control. Maize use was found to reduce exponentially with increased depth of topsoil removal, with an average of 55% loss when just 5 centimeters of topsoil was removed, signifying the potential of soil erosion to cause appreciable crop yield reduction with just the removal of a few layers of nutrient-rich topsoil, and confirming an earlier study. Soil and climate change. Soil is the largest terrestrial carbon pool and contains more carbon than in the atmosphere and all the vegetation combined. It holds approximately 1,500 to 2,400 gigatons of organic carbon in the first meter alone. By comparison, the atmosphere holds about 800 gigatons and the terrestrial vegetation about 450 to 050 gigatons. Soil serves as a sink for the sequestration of organic carbon and thus a major consideration in climate change remediation. The interaction between soil and climate involves coupled cycles. For example, as the climate warms, the rate of decomposition of organic matter increases, reducing the amount of carbon sequestered in soil. On the other hand, higher atmospheric CO2 increases plant growth and thus more carbon input into the soil. In 2009, in a study of the carbon, we studied the carbon and nitrogen fraction in soil aggregate sizes from different land use types in an horticultural soil in Nigeria. And this showed that land use decisions strongly determine soil carbon storage, and that cultivation practices that encourage the higher contents of this fraction can be used to mitigate the impact of climate change. In another study, we monitored the emission of CO2 at frequent intervals and equally reported CO2 emission from soil, reaching its peak at 12 noon, coinciding with the period of maximum daily temperature, as shown in figure 6. Organic matter and soil architecture. Soil aggregates are the basic structural units of soil, and their stability determines the soil's ability to support crop production and maintain environmental quality. The hierarchical aggregation model proposed in 1989 explained that microaggregates are stabilized mainly by electrochemical forces and mineral interactions, while macroaggregates are bound primarily by organic matter. research we did on some Nigerian soils provided strong evidence to support this model. For example, in 1999, we showed that incorporating plant residues increases light fraction organic matter, which soil microbes convert into heavy fraction polysaccharides that bind tightly to dense soil minerals. This process is enhanced aggregate stability by stimulating microbial population of extracellular polysaccharides and fungal exudates. Our study also identified tillage as a major cause of soil structural decline, noting that residue incorporation combined with reduced tillage can reverse this degradation. This was further confirmed by our study. We also found that macroaggregates contain younger, more labile carbon, while macroaggregates protect older, more humidified carbon through strong mineral association. Tillage disrupts macroaggregates first, releasing labile carbon that oxidizes to CO2. Thus, long-term carbon sequestration must be assessed within microaggregates and clay fraction, where carbon is physically and chemically protected. In another study in 2020, we examined soil organic matter fractions under different land uses and found that microaggregates store more stable carbon, while macroaggregates contain more unstable fractions. Our study also showed that earthworm casts are richer, about 2 times richer than surrounding soil and structurally stable, confirming earlier findings. Earthworms act as biological fertilizers by concentrating organic matter and minerals and improving soil structure and porosity. We also recommended farming practices that protect earthworm populations, such as minimizing pesticide use and retaining plant residues to sustain soil health. Spatial variability of soil physical properties. Soil developed from parent rocks and minerals mixed with organic materials under long-term climate influence. Because parent material differ, soil properties vary spatially, and understanding of this variability is essential for accurate soil evaluation and management. Soil variability driven by pedogenetic processes is regionalized, thereby nearby locations, which imply that nearby locations tend to be more similar than distant ones. Classical statistics cannot adequately describe this pattern due to spatial dependence, but geostatistics provides tools for quantifying spatial structure and interpolating soil properties. Using geostatistical methods, in 1992, we demonstrated significant spatial dependence in soil moisture, conidines, and gravel content under an oil palm plantation, with all variables fitting a hyperbola model. A follow-up study applied virogram parameters and kriging technique to estimate these properties at unsampled locations with estimation errors below 3%, thus confirming the accuracy of geostatistical interpolation. Traditional soil mapping often combine soil properties rating into stability classes, but this can misrepresent actual soil potential. To improve this, we in 1996 introduced the multiple variable indicator kriging technique, which converts soil property data into binary indicators based on threshold values and integrate them into a single probability index. Kriging was then used to generate suitability maps showing the likelihood that a location met all the criteria. The MVIK accommodates both quantitative data and qualitative factors, such as landscape position, making it valuable for agricultural planning and environmental monitoring. This approach has since influenced modern soil mapping software. Soil water management. Water is the main medium for nutrient transport in soil and a key regulator of soil temperature. As a universal solvent, it drives nearly all chemical and biological reactions in the soil. Soil water content is measured on weight or volume basis using methods such as oven drying, electrical resistance, neutron scattering, gamma ray attenuation, and time domain reflectometry, also known as CDR, which is a newer technique and relies on the high dielectric constant of water compared to soil solids. The dielectric constant of water is 81, and those of other soil solids range between 4 and 8, and that of air is 1. Because soil dielectric properties depend largely on water volume, TDRU measures soil moisture by sending a voltage pulse through two rods inserted into the soil and recording the signal's return time. The time interval is directly related to the volume of soil water. In 1985, Tubb and Davis developed a mathematical relationship for this as presented in equation 8. This was further upgraded to an empirical equation presented in 9. Based on this empirical equation, in 2015, we designed and fabricated a TDRU-based sensor with data logging capability for the measurements of soil water content, as presented in tables 2 and 4. This equipment was used by a PhD student to determine soil water budget required for the computation of crop coefficients and water usage efficiency for some indigenous vegetable in Nigeria. The cost, we fabricated this equipment for a cost less than $50,000, compared to $10,000 for a similarly imported device. Soil strength, trafficability, and impacts on crop production. Soil strength is the ability of soil to resist deformation or structural failure, governed by cohesion and internal friction. It varies with water content, bulk density, texture, and organic matter, and it is measured as a tensile, either as tensile strength or shear strength. In 2017, we observed that soil strength increases with depth, but in the study, and also decreases with soil water content on the study. In a major advancement, we also, because soil strength has been measured indirectly, so we designed and also built a data logging pressure transducer to measure the exact force seedlings must exert to emerge from compacted soils. This instrument never existed. Using this device, we show that okra requires higher emergency pressures ranging between 0.3 to 7.3 millibar than maize, which require 0.03 to 1.73 millibar across compaction levels. Capillary irrigation. The Bible in Genesis chapter 2, verses 5 to 6, say that, and every plant of the field before it was on the earth, and every herb of the field before it grew, for the Lord God had not caused it to rain upon the earth, and there was not a man to till the ground. But there went up a mist from the earth, and watered the whole face of the ground. Genesis chapter 2, verses 5 to 6. This passage in the Bible record of a time before it started to rain on the planet Earth. And verse 5 specifically mentioned that how water came to wet the soil, and that was through capillary action. The rate and direction of water flow in soil is governed by its energy state or the potential difference. Water generally moves from a region of higher potential to a region of lower potential. Based on this, we again designed and fabricated a PVC-based capillary irrigation device for use on the field. It consists of a buried PVC pipe that serves as a reservoir for water and capillary tubes that are filled with graded sand. Through water is conducted upwards and directly to plant roots in response to evapotranspiration demand. The system can also be used to supply crop nutrients through fertigation, thus ensuring better utilization of fertilizer, reducing the cost of fertilizer application. The device significantly, when we use it, significantly increased the yield of leafy amaranth by about 130% compared to traditional sprinkling irrigation. In addition, the capillary irrigation method saved about 8 million liters of water per annum per hectare compared to manual irrigation. Soil and recreation. Soil not only serves the purpose of agriculture, but also supports recreational activities. Sports such as golf, football, handball, and others require good turfs. In order to improve the management of the Obafemi Awolowo University main football field, we have been collecting, for the last 7 years, we have been collecting geospatial data of soil properties and turf head to identify the sections of the field that is most impacted by leg traffic during football games. This is to enable us recommend a more precise management practice to maintain good quality turf. Preliminary analysis of data revealed an unusual pattern, which is that gradual loss of finer soil particles over a relatively short duration of time. This means that the soil of the field is becoming more sandy. This is surprising because soil erosion of such magnitude is not expected under grass cover. On a careful observation of past activities on the field, it was suspected that the fine soil particles are being lost due to wind turbulence generated at the landing and taking off of helicopters, especially when this field is dry. We can see an example there. We can see a lot of sand that is being blown by helicopter during landing and taking off. Mr. Vice-Chancellor, sir, on the basis of this, I recommend that the university should wear the field before landing and taking off of aircrafts from the field. Or in the alternative, construct a helipad for use of our VIP guests, since it is likely we'll be having many more of them soon. Indigenous Vegetables Project. In 2011, in collaboration with Osun State University, Cape Breton University, and the University of Manitoba, both in Canada, our multidisciplinary team consisting of agronomists, soil scientists, plant pathologists, plant physiologists, food scientists, agricultural economists, agricultural extension scientists, and sociologists, among others, won a multi-million-dollar grant from IDRC and CEDA, Canada, for study of the underutilized indigenous vegetables of southwestern Nigeria. I was the principal investigator for the Obafemi Awolowo University. We identified and documented 50 underutilized vegetables that were almost going into extinction, out of which we developed detailed agronomic best cultivation practices for 10. We trained more than 1,400 farmers, of whom more than 50% were women, on best agronomic practices. These techniques enabled them to increase their yield by about 40%. We also launched a very effective radio campaign, tagged Ramo Elefo, which reached thousands of listeners daily. Based on the success of this project, IDRC and Global Affairs Canada awarded a follow-up grant of $4.8 million for the team. Now we join with the University of Parakou in Benin Republic and University of Saskatchewan in Canada to scale up the earlier project. And this, the study was carried out in both Nigeria and Benin. We introduced the agronomic technology of fertilizer microdosing combined with organic manure that significantly reduced the cost of vegetables production and also improved soil health. An innovative irrigation technique was mentioned earlier was developed out of this. Other innovation developed during the course of the project included: 1, low-cost sun dryer and charcoal-powered oven for converting fresh vegetable leaves to dry ones that stored for 12 months without losing their taste or nutritional values. 2, a protocol for extraction of polyphenol from vegetables and their use for fortification of local food, juices, and pastries. 3, demonstration of the ability of polyphenols from Terpharia occidentalis and Amaranthus radius to reduce blood pressure of spontaneously hypertensive rats by up to 50 milligram mercury. Number 4, fortification of bread and chin-chin with vegetables to extend their shelf life by up to 3 days. The project reached about more than 400,000 farmers, both in Benin and Nigeria. In addition, 5 PhDs, 8 masters, and 15 BS students were funded and sponsored by the project, while 2 technical staffs and 5 academic staffs were sponsored for short-term trainings in Canada. Soil health and the environment. Soil health is defined as the continued capacity of a soil to function as a vital living system by recognizing that it contains biological elements that are key to ecosystem functions within land use boundaries. These functions are able to sustain biological productivity of soil, maintain the quality of the surrounding air and water environment, and as well promote plant, animal, and human health. Soil health is the expression of the ability of soil to meet its range of ecosystem function as appropriate to its environment. So under this, we looked at the effect of bush burning on soil and the environment. We investigated the effects of fire burning during cultivation, during land clearing on soil subtility, which is the ability of soil to absorb water by capillary, which decrease with temperature of the fire, while soil water repellency or hydrophobicity increase with increase in temperature of burning. However, burning was found to improve the immediate soil chemical properties and maize yield. Further studies using a standard erosion plot were on this plot recorded a runoff at the soil water loss ranging from 10 to 13 mm of water. When the temperature of burning was about 200 degrees Celsius, and when it was increased to 500 degrees Celsius, there was a lower runoff also recovered. However, the concentration of nitrates in the runoff significantly increased with the burning temperature in the 3 seasons of the study. And this is a major worry for surface water contamination. Contamination and environmental toxicity. Mr. Vice-Chancellor, sir, a major contribution to the contamination of soil environment is uncontrolled industrial waste of effluents. In 1999, we demonstrated that soils and vegetables around the major smelter in Jos, Nigeria, contained extractable lead that was far in excess of WHO limits, with toxicity potential ranging from 0.15 to 26, depending on the distance from the source of lead. Later, we reported that dump sites in Ile-Ife had vegetation that were rich with zinc, copper, and cadmium, with concentration ranging with concentration increasing with the age of the dump. Transfer factors were lowest for lead and highest for cadmium. Also in 2016, we reported transfer factors values for maize and okra grown on soil amended with rock phosphate and cow dung, confirming that rock phosphate also introduced heavy metals and that organic waste enhance their plant uptake. These findings highlight the need for strict monitoring of soil and crop metal levels when organic waste are used as fertilizers. Concluding remarks. Sir Vice-Chancellor, sir, in this presentation, I've tried to draw our attention to how physics provides the platform for defining and quantifying soil architecture and predicting the possible implication of soil disturbance on soil processes and the capacity of soil to provide its ecosystem functions. Soil physical shape and poor configurations influence the rate of chemical and biological processes taking place within the soil. Agents of soil degradation include soil erosion, cultivation under unfavorable water regime, soil contamination with pollutants, and soil exhaustion due to overuse. All these negatively impact food security and soil health. A healthy soil is a productive soil. A productive soil leads to a food secure nation. And a secure nation is able to withstand its ground in face of external aggression. Therefore, I recommend that a national information system be established in Nigeria. And Nigeria must urgently build a comprehensive soil database covering physical properties such as mentioned earlier. This will support agriculture, infrastructure, and national defense. There should also be a legislation to enforce a national soil conservation policy to guide on crop and soil-specific tillage practices. My teaching and community service. In teaching, Mr. Vice-Chancellor, sir, I have had the benefit of teaching some of the best brains, and God has helped me to bring the best out of them. It is always my delight to see them performing excellently around the globe. Apart from hundreds of undergraduates, I have successfully supervised 24 masters and 7 PhD candidates, many of who are now professors in Nigeria, in the US, and Canada. Many of them are following us online from different parts of the world. I have also successfully linked many of my students to scholarships and grants for further studies. Town and gown. Mr. Vice-Chancellor, sir, I have served as consultant to different companies involved in agricultural development projects and on environmental impact assessment and on the impact of developmental projects and oil and gas exploration in various parts of the country. These studies have made me to traverse the length and breadth of Nigeria, from the rivers and creeks of the Niger Delta to the desert fringes of the northern Nigeria. In response to complaints by tomato farmers in Wasimi area of Osun State, who suddenly started to observe a drastic reduction and even failures in the yield of their tomato, our team, consisting of Professor Adiagbamuson, Kola Adekunle, and I, visited their farms. The studies we conducted revealed the cause of the premature abortion of tomato flowers to be due to nematode infestation. With a little ground from the university town and ground, then headed by Professor Adeusi, our team set up an experimental site on the farmer's field and successfully developed a farmer-friendly indigenous method with the use of African marigold plant to control the nematodes. And the farmers were able to successfully continue with their tomato farming. Administratively, I've had the opportunity of serving in various capacities in the university. I was a member of departmental and faculty examination committees, acting head of department, and substantive head of department, dean of the faculty of agriculture, representative of the university senate on the governing board of IR&T. I was also a two-term representative of senate and the university governing council. I have also chaired various university ad hoc committees. Acknowledgements. I want to use this moment to acknowledge my mentor, my supervisor, who is inadvertently absent here because he had to attend the committee of pro-chancellors of State University in Kano at the moment. That's Professor Patrick Oladikwaino, who supervised my MPhil, my PhD degrees. He's like a father figure to me. I've learned a lot from him. His patient, uncommon intelligence, his words of encouragement have been of tremendous help in my academic career. I'm forever grateful. I also acknowledge Professor A.F. Oluwole for the access to environmental physics laboratory of the Department of Physics during my PhD study, and also all the scientists I work together with in the laboratory. I acknowledge my appreciation goes to every member of the Department of Soil Science and Land Resources Management who have contributed to my academic progress, starting from those who taught me and also my present colleagues in the department. I acknowledge you. I also acknowledge the Inaugural Lecture Planning Committee. You have been wonderful. I am grateful. I'm very, very grateful. I want to thank all my students and mentees who have made my academic journey very interesting. Many of them are making waves in different parts of the world. And I said, it is always my joy to receive news of your success and exploits. And some of them, many of them are professors in Nigeria, in Canada, USA, and in different other parts of the world. On international level, a string of coincidences brought Professor Wole Akinremi and me together in 1996 while I was on a postdoc in Denmark. This has initiated a lasting friendship and a productive academic collaboration between us that has blossomed with years, and through which many staff and students from the Department of Soil Science received trainings at the University of Manitoba, and has led to a strong and virile OAU community in Winnipeg, Canada. And this also led to the RDRC research grants that we obtained. I appreciate my research team that we have worked together at the University of Manitoba. We said teamwork make the dream work. I also want to thank the soil physics team at Aarhus University, Canada. I want to say mange tak for all. Also, I want to appreciate the research team that I work with in CNN, ICE, Pisa, Italy. Grazie mille. I thank the Cape Breton University team that also had productive works, association together. Very big thanks to you. And also to the team at the University of Saskatchewan, Canada. And also the team at the University of Dublin in Parakou. I say merci beaucoup. I acknowledge the support of various granting agencies that has enabled me to accomplish in my academic journey. I want to thank Mr. Vice-Chancellor, sir. Please permit me to recognize many people who have contributed to my spiritual development. First, I thank God for our General Overseer of the Redeemed Christian Church of God, Pastor and Pastor Mrs. E.A. ADEBAYO, for the leadership, the spiritual leadership you have provided. I'm also grateful for the leadership of my pastor of the region, Pastor Ajichola, the pastor in charge of Osun Province 7, Pastor Timitokwe, and his assistants, Pastor Salami and Pastor Ayonwale. To my family, I appreciate my parents, Mr. SIMEON Abegunde Oyedele and Chief Mrs. Hannah Oyedele of blessed memory, for giving me the best education they could hardly afford. And to my siblings, Chief, please stand up for recognition, Chief Mrs. Bamidele Oyedele, and to my sister, Mrs. Abigail Balogun, who had to drop out of school so that she could take care of us, even though she was the brightest among us. Appreciation. To my immediate elder brother, Tamplana Kayode Oyedele, who was my home teacher and ensured that I was always had advanced knowledge ahead of my classmates. I thank you. And I use this moment to remember my late younger brother, Toyin Oyedele, his moment lingers. I also appreciate Magistrate Funke Oyeniyi, who is our baby sister. My appreciation goes to my brother from another womb and his wife, Evangelist and Mrs. Fola Alao. I'm grateful to Pastor and Mrs. Some Kayode and Mr. and Mrs. Ojo Seriki. I want to appreciate God for my mother-in-law, Mrs. Agnes Hassan, and also my father-in-law, Pastor Bola Hassan. I'm indeed very grateful. I also want to thank God for my other children from another man's line. They have been wonderful. I want to use this moment to recognize just two people that are the two worthy alumni in this occasion. I want to appreciate God for Kayode, the CEO of that's please stand up for recognition. I've forgotten his company will be making an endowment before he leaves here, before he leaves OAU. There's an endowment that he'll be making. I also want to thank Mr. Olawale Hassan, the CEO of Novak Board Pay. Welcome. They are worthy alumni of OAU. And to my biological children, Ayomikun, Jesu Tomisin, Temini Jesu, and Mojoyi Jesu. Thank you for enduring those years when I was either always on the road, in the air, or in the office. Thank you for making us proud. To my wife, Folashayo Aweke Oyedele, stand up for it. My partner, my encourager, and a jewel of inestimable value. Thank you for your love and care. I want to also appreciate the university administration for the support. Without the university administration, everything I have achieved would not have been possible. I want to appreciate the Vice-Chancellor on behalf of the university administration. Finally, I give glory to God Almighty for the gift of life and for lifting me up from the miry clay and setting my feet on the solid rock. I sing unto you. Hallelujah. Hallelujah.
Certificate presentation. Obafemi University Ile-Ife, certificate of presentation of inaugural lecture. This satisfies that Durodoluwa Joseph Oyedele, a professor of soil physics and soil conservation, Department of Soil Science and Land Resources Management, Faculty of Agriculture, Obafemi University Ile-Ife, delivered the 419th inaugural lecture titled Nexus of Physics, Soil Architecture, Sustainable Environment and Food Security. This day, April 28, 2026. Congratulations.
With the kind permission of the Vice-Chancellor, may I humbly invite the wife to please come and join her husband here.
Just roll from side to side like this. Cause your mercies, oh baby. Tabi mo dara, tabi tori mo mo adura Tabi tori bobo iwe ti mo kare. Anu Olúwa tó gbé mi ró. Mo ní kí mama rí ṣe torí mo ní bàbá ìsàlẹ̀ mo kọ́ ẹni fi balẹ̀. Àánú yìí ó, àánú Olúwa ó. Bóyá bí mo bá ṣe ń jáde nílé àánú. Bí mo ṣe ń kórè délé àánú. Nítorí ire ṣeré àánú. Èrò máa tẹ̀lé mi. Bóyá pàdé bí mo ṣe ń kọ́lé mọ́lé o. Bí mo ṣe ń kórè wọlé o. Nítorí ire ṣeré o. Èrò máa tẹ̀lé mi. Ó ní kí n ta testify. One more time. If it wasn't for the mercies of God, where will you and I be today? Àánú tí a rí gbà ló jẹ́ kọ́kọ́ ń gbé ìjà wájà. Òní kí màmá iṣẹ́ torí mo dára tàbí torí mo mọ̀ àgbà.